Okay, hi. I'm Kay. I'm the CEO at Mortar Data, and I'm joined by lead engineer and one of my co-founders, Jeremy. This is us. So what Mortar does is we make a platform for large-scale data science, for data scientists to use. And so as part of that, we have to make Hadoop and Hadoop-related technologies much, much easier on a variety of dimensions. So what I'm going to talk about is we've built this open source, modern framework for elastic MapReduce. So we got into this work because we came out of an education technology background. We built products that reached 1 in 10 students in the public school students in the US. And we were doing things like predicting whether they were on track for success in 12th grade, or whether an individual teacher was adding to his or her students' literacy adequately. And basically what we were doing was very large-scale data science, although we didn't call it that at that time. So that's how we got into this. And I'm going to, as I said, sort of focus on just a small piece of what we're doing. I try not to walk behind you too much. Just a small piece of what we're doing, which is specifically around making elastic MapReduce really easy. That went too far. OK, so this talk is technical. I will try to keep it high level, so if you're here from more of a business perspective, you should be able to follow what I'm talking about and why it's important. But if you don't know how to follow what's happening in a terminal, or you've never actually used Hadoop or elastic MapReduce yourself, you're probably going to lose some of the subtlety about what we're showing and why it's really important and how it's a big step forward. We're going to do a lot of demoing, actually, live demo. OK, so Hadoop is great technology, very scalable, rock solid, can do all kinds of things with it. Trouble, of course, is that it's hard to set up and run and maintain and monitor. So elastic MapReduce is fantastic. It takes those problems away from you and handles them as a service. But there's still a lot of room for improvement around specifically a modern framework. And so by a modern framework, I mean things like these that are coming up. Code frameworks that have these sort of goals. In our case, we're actually targeting 10x productivity increases if you're doing data science on top of Hadoop. Not all those different frameworks can achieve that much, but big increasers of productivity. We get there through making it easy to collaborate. So data science is very hard typically to collaborate around. Just very high levels of friction between discovery of something that you want to use or reuse or contribute back to, installing that everywhere you need to, getting all the data set up, and contributing it back in a way that we know is correct. So collaboration is one of our goals for the modern framework. Doing free development with Hadoop and making that really fast is another one, because that's another huge piece of friction. If you're using Hadoop, it costs a lot of money every time you do anything, long iteration cycles. Another one of our goals is being able to do automated testing, because you want to know, if your business depends on these things, you want to know that they're correct. Debugging, so at runtime, all your tests pass, but things are too slow, or it's not quite what you expected. So runtime debug is another part. We want to be able to get reproducibility. So what did I do in the past? How can I do it again? And then there's sort of a grab bag and more. A series of things that the framework improves on top of elastic MapReduce. OK. As a quick aside, just to make this abundantly clear, Hadoop is used for a lot of things. We're particularly focused on a data science use case. A lot of times, Hadoop is used basically as a data store or as a database, whether you're using HBase or Hive. We're not covering that. It's really all about how do you ingest data from one or a variety of data sources, move it through a complex multi-part pipeline, and then come out the other side with models or more data or visualization or that sort of thing. Here is quick look at sort of, there's the open source framework that you install on your own machine. You iterate locally. You work very quickly. Then when you're ready to run in the cloud, you're ready to run on elastic MapReduce against a large data set, then we'll show you, there's a migration. You move your code, it's one button, into the cloud, and it executes there. And I'll sort of try to call out when we make that transition from working locally to working in the cloud. It should be fairly clear even if I don't call it out, but we'll try to delineate that. So for the purpose of showing all those different things that I was talking about that are our goals for an open framework, we're going to use some sample code. It's really very simple. It's not real data science, but it's simple enough that we can actually demonstrate what's happening, and you can probably understand it in the context of a very quick demo. And so we're going to find, in a sort of naive way, the most popular projects on GitHub month by month. Okay, so our first goal is around collaboration. We want to be able to easily run code that other people created. As I said, there's a ton of friction around that right now, particularly on Hadoop, installing across a variety of technologies, getting the right data set up, getting all your dependencies at the right versions. It's a nightmare. So we want to be able to do that really easily, and we want to be able to contribute our changes back. So at this point, we're going to switch over to Jeremy. He's going to do some of our first live demo. So what he's doing now, we've pre-installed the open source framework called Mortar. It's got a gem installer, so you can gem install Mortar to get it yourselves. First thing he just did, he typed Mortar projects. That shows you all the projects that are inside of a private Git repo that are available to bring down onto your machine. So he just cloned it. Went from having nothing to now he's cloned this existing project that presumably does something. There's what's inside of it. It's got a variety of directories where different technologies go. And the next step is, OK, great, we've got code. It spans various technologies. Presumably it knows how to talk to each other and do complicated things. But we want to be able to run it. So,
Sorry.
Yeah. But we want to be able to run it. And so he's going to fire off a first run command, which is actually called watch, which I'm going to talk a little bit more in a second. And so what watch is going to do is, in a sandbox on his machine, pull down and install the dependencies. So you can see it's going to install pig, it's going to install Python, Jython, various things that this project needs in a sandbox, so it's not going to mess with the rest of your environment. This is a one-time setup, and it's dependent. The speed of this part is dependent on your internet speed. Each additional run isn't necessary once you've got these things installed, so it goes faster. So while that's running, it's almost done. But while that's running, we flip back over to the our next goal is we want to be able to do free development, and we want it to be really fast. So you need to be able to iterate quickly, no cost, and it should be resilient to errors. So when errors come up, you need to be able to figure that out really quickly and fix them. So OK, go back to the demo. OK, so we're still installing. So I'll talk through what's about to come up after the install is finished. So watch actually watches the entire file system. So it looks for any changes in your Hadoop code, your Python code, whatever, your sample data that comes along with these projects. And if there are any changes that occur, it will pick that up and update an interface. It's a browser interface, but it's running here locally, to usually show you in sub-second what's happening and what's changed. So if we scroll up to the top here, this is a very simple pig script. And let me scroll down a little bit, just the first step. Yeah. So what we're seeing is on line 22, here's a pig statement. And then below that, we have a sample of data that is coming out of that step. And we follow the same sample of data all the way through the script. So do you want to talk about what we're seeing here?
Sure. So you can see here, what we're doing is just loading in a bunch of GitHub events data. So GitHub has made public a lot of the API calls that are made for public repos. And they have a bunch of different events, I think about 17 total. But in our naive implementation of the top repos, what we're going to say is every time someone forks a repo or every time someone watches a repo, that sort of gives that repo a point. And we're just going to find out for every month what are the repos with the most points. So this is showing at the start, here are all the different events that are coming in from the data that we're loading. And you can see that they include push events, watch events, and actually expand this out. There's pull requests and a whole bunch of different events as well. And you can see then that the first thing that our script is actually going to do is say, only keep the fork or watch events. And now you can see that the data is actually showing you that those push and pull request events are gone. So we're left with only, in this case, watch events. Or if I expand this out, you would see the fork events as well. And so then the next thing we're going to do is we have this date string, which is the time that the event actually happened. But all we care about is what month did it happen in. And so our next statement in the pig script is just going to take out the year-month combination. And so you can see then, at that point, what we're left with is just the repo name of the event and the time that it happened in. The next step in the script is we're basically just going to group those, and we're going to roll up those events for each month for each repo. And so you can see here we had a number of different events for this Corey Simmons slash Jeet, and here we are left with a score of 4 for the month of February this year. And so now we have these scores for all of the repos. We're going to find the top 5 in each one. And one of the things with Watch is that because it's just taking a small sample, things like the top 5 in this case became the top 3 because it didn't have enough data for the top 5. And then the last step is we're actually going to sort those to make sure that we're sorting and showing the most popular one at the top and the least popular at the bottom. And so one of the neat things about Watchtower then is I can actually make changes to my script and immediately see what the effect is. So let's say instead of sorting descending from sort of the highest score to the least score, I'd left it as, let's go in and change that script.
So you can use whatever editor you want. You know, it's just a browser running alongside.
So I'm going to remove that and change it to ascending and save it. And as soon as I save it, you can see I just got back in time. You can actually see that the Watch is actually showing you how that change is affecting that data that's flowing through your script.
So where's it finding the source data that it's operating on right now?
It's finding it from wherever you tell Pig to find it. So in this case right now, I actually have a sample set of data that's in my Mortar project. So it's in GitHub as well. But it can just as easily work with S3 data as well.
OK, so then now I think one of the other goals we had was to make sure that we could discover errors easily. So let's take in and mess up the syntax.
So let's say I forgot the by keyword. I can switch back and see then that Watch is actually going to show me that I had that syntax error there on line 67, column 26, and that what it's expecting is the by keyword. So I can go right back, 67, move over, save that, and the error goes away once I fix that problem.
OK, so let's go back to the, yeah, thank you. Oh, and so for the no-cost part, since this is all free, open source, running on your own local machine, this is all free. Great. And you haven't had to spin up any cloud resources. So our next goal is around testing and debug. So we want to be able to write automated tests. And we also want to be able to see what's happening at runtime. So we're going to cover both of those. I've got to switch back over to your screen. OK, so here is a test that is written in Python. It's checking. You can see the first 3 rows show that there's 3 repos, and their popularity is 327. And then we want to assert that at the end, the repos are in 723, descending order. Now, since we just made it ascending, this test is going to break. And it'll take a moment to run, because what it's actually doing is firing up Hadoop on this laptop and running it. I think it takes like 15 seconds or something like that. But what's interesting about these automated tests are it's Python, so it's fully flexible. You can make any kind of assertions you want. It doesn't have to be just string matching. You can do integration testing, meaning you can look at the data that goes in the top and then make assertions about what comes out the bottom to make sure the whole thing works. Or you can inject data into right before any statement. And so that's a really big deal, because that way you're not trying to mess around and set up just the right sample data set at the top so that it flows through these 5 or 6 statements to reach the bottom where you want to assert about the order and make sure that everything flows through in the right way. Even if you did get that right, then what happens if somebody comes along and they change some of the code that came above and it breaks your tests? So it's really nice to be able to just inject just around the pieces that you want to be able to test. OK, so that failed. Great. And I guess you just fixed it, and now it's going to pass. So it's great for knowing that what you've written is correct, that it stays correct, it doesn't get broken. We've also found that it's really useful because now you can start to integrate and rely on the data science that you're doing on Hadoop with the same infrastructure, continuous integration infrastructure that engineering is using. So you just hook this right in, and you make sure that nothing's broken. OK, so now our test passed. Next thing we want to touch on is about debug and runtime debug. So this is the point where we're going to make a leap, and we're going to actually push something into the cloud for execution in Elastic MapReduce in Mortar. So here's the command, Mortar run this particular project, which is called top projects, and give it some parameters to be able to run in the cloud. And what it just did is it took a snapshot of the code, all the dependencies, all the artifacts, pushed them up to the cloud for execution. And we can pull here, we can use an API to. This first step, it's validating the script. This is actually really useful. So if you have a typo or you can't access some of the data in the cloud that you thought you could access, before you spend time installing all that software onto your Hadoop cluster and spinning it up and being charged for it, and then finding out, oh, typo, or I need to change the access control. We actually check all those things for you. And then once it passes, then we will spin up a Hadoop cluster or install it onto a Hadoop cluster if you have it running. And so then Jeremy just followed a link that was made available there. If you were at the keynote yesterday, we were one of the winners of the open source software award from Netflix for this work. So this is a tool that they open sourced about 6 months ago called Lipstick. And it does a whole bunch of really nice things to help you dig in and understand exactly what's going on at runtime and after your job is done. So actually, Jeremy, you want to talk about this?
Sure. One of the fun things with demos is always figuring out what's the proper zoom size for showing everything. So while this job's getting started, I'm actually going to go and look at a job that I already ran so that we can sort of see what it looks like at the end, and then we'll return to the running job. So let's go to this one here. And go to the visualization, zoom in. So what Pig is doing under the covers is it's taking your script and compiling it into a bunch of different Hadoop MapReduce jobs. And so the first thing that Lipstick is really doing is showing you in a really clear graph here how your script is actually being run in MapReduce. And so if I scroll down, again, it's sort of hard zoomed in this high, but you'll see there's about 4 different boxes here, which are the 4 Hadoop MapReduce jobs that are actually created from your script. And it shows you then what each of your lines and your aliases from your Pig script, how they actually map to the Hadoop MapReduce jobs. And if you look on the right, then it will also show you the timing for each of those jobs. So I can see here that the 005 one, which is the first one from this set, from this script, took 2 minutes. And then there was another one that took 1, and then 2 that took 30. And so one of the common problems when you're working with large and complex Pig scripts is actually figuring out where's your job taking time and how big of a cluster do I need and all that sort of stuff. And so this is nice because right away at a glance, I can see here are the aliases in my script that are actually taking most of the time. I can then click on that and drill into even more information about that job. So again, a clear list of the aliases from Pig that are in this job. I can see the number of map and reduce tasks that were required, and then a bunch of those stats about the job. And if you've ever worked with EMR or Hadoop, you'll know that a lot of this information is only available by drilling through about 5 different links in your job and task trackers, and sometimes you have internal IPs and the links don't work, and it's nice to be able to see at a glance what are all of your stats right here. And the other nice thing is because we're actually tracking this, once your cluster is reaped, so even though you're not paying for it, we actually have all of this information. So you can go back and look at a job that you ran a month ago and see what were the performance characteristics of that job and how have they changed over time and that sort of stuff. Another nice thing here when I scroll over here is I can see at a glance how many rows are coming into the job. And then, so here you can see we loaded 40 million GitHub events, and we spit out about 1.7 million. And so even, not even for performance, but even for just correctness, at a glance you can see, does this data make sense? Did I make a join that exploded my data that I wasn't expecting? And if you click on it, Lipstick actually grabs a small sample of your data from each of these passes through the Hadoop jobs. So I can see, does this data even make sense? Was I expecting the year-month string to look like this, the item string or the score? And I might have been talking too long. We'll see how that other job is doing. And so the other nice thing about Lipstick is when it's actually running, you're seeing this progress here as well. And so you can see, is my job stopped? Has it not made any progress for 2 hours? Here's the link to it. We give you the links to actually find out what are the details about that. And you're seeing this happen as it's actually running. And then the last thing that we sort of track is we're actually capturing the Pig logs as well, just so, again, what we want is so you can go to one place and get all the information for your job. And so here are the logs that are streaming through as your job is actually running. Should have probably disabled that. And again, this is all kept, even after your cluster is destroyed and you're not paying for it, we still have all of this data.
So we've covered a whole lot already. Maybe it'd be a good moment to pause and make sure that this all makes sense. And if you guys have any questions, ask questions about how, how this works or how it fits together or anything else. Yeah.
How dependent is it on pig as the underlying
Right now, it only supports pig. It won't be that way in the future, but that's what we decided to use. Is there, you thinking of like scalding or some particular other?
Yeah, or custom.
Just MapReduce. Yeah. Yep. Yeah, we focused on pig because it provides a nice high-level abstraction where you can understand what's going on just by reading it without being a deep engineer, and because of these things in the community like lipstick that we can build on top of. So. Yeah.
How much of this is lipstick and how much is mortar?
So all the basic, well, except for the timing information.
Yeah.
Yeah, except for the timing information on the right-hand side, all the basic functionality is lipstick, and then our contributions were around making it portable, making it so that you could actually spin up your own lipstick instance, making it embeddable, some finessing around the graphs and making them zoomable and that kind of thing. Yeah. Any other questions before we just keep going? Okay. Okay, so those were those goals. Next goals are around reproducibility. So we want to know exactly what was run. We want to be able to do a one-button deploy to like a staging or a production environment, and we want to be able to roll back. So back over to the demo. Mortar's actually snapshotting everything you do. So it snapshots the exact parameters that you used. It sticks the code that you ran, all of it, in GitHub. So you can always go back and see exactly what happened. So this is the combination of this with the lipstick stuff that Jeremy was just showing is really powerful, because you run something one day, you come back in 2 weeks, you run it again, you go, I don't think that took 5 hours before, and you look and in fact it only took 1 hour. Okay, so now I need to drill in and figure out what's changed. Because it's all backed with snapshots in Git, you can just do, you can just use built-in GitHub diffing functionality, see immediately what changed, and look at that. Okay, the next thing we had was one button deploy, and so this is an idea that was popularized, but I think by Heroku. It may have come out. I mean, I'm sure somebody else created it first, but I think they popularized it. It's a very powerful concept of if you want to release to production, all you should have to do is push to a particular branch in GitHub repo. Everything should get picked up and go from there. And so we took that concept and put it in Mortar as well. So you can pick any, take your repo, pick any branch, pick what you want to run within there, and it'll always run the latest at that point. And so that also, that's how we get rollback too. So you have a production branch, you release to it by pushing to it. If you need to roll back, you just change underlying Git, and you've just rolled back. Again, because these projects in the framework are all totally self-contained. They have everything they need to run. Okay, the next goals that we had for the framework. So the miscellaneous time. Okay, so we want to be able to do easy scheduling. I guess we'll take these one by one. We want to be able to do easy scheduling. And that's, here's a GUI interface to this. You can do this all through API too. But you can, as Jeremy was just showing, you can pick which branch you want to run, what project, set up what cluster size you want to run. You can get notification when something completes or when something fails. And that's all you have to do to be able to schedule. And if you want to actually schedule that, then it will run from then on. So apparently the first of every day at 1 a.m. UTC, this will kick off. So that's really convenient. The next goal we had was to be able to easily use other technologies along with just Hadoop with Pig. So using Python is a big thing for data scientists, particularly CPython packages that traditionally don't work with Hadoop very well because it's not written in, for the JVM. So things like NLTK and SciPy and NumPy. So we extended Pig and got those patches back into Pig 0.12, which is now released. And so you can use real Python directly from Pig. This is now we're moving outside of the example that we had because there wasn't a good way to sort of show using multiple technologies within the GitHub example. But the first step just shows here's how you would load data from MongoDB. Connection string and a schema, that's all you need. The next step shows calling Python, where we're figuring out top 5 bigrams using NLTK, which is a natural language processing toolkit. In Python, that's all you have to do to do that. And then if you want to write out to Dynamo, you can do this. And this store is smart about the throughput that you have provisioned for Dynamo, so it won't try to exceed that. It'll just go right up to that and load as fast as it can. Okay. So the next miscellaneous goal is being able to find your results easily. And so again, going back to the job history, not only are you getting your parameters and your code snapshots, but we also have a direct link to your results. So you can always go back and recapture those. And so this is the job that we just ran, figuring out the most popular GitHub repos by month. And I don't know if you can read that, but Bootstrap is popular.
I think it's in every month.
Yeah. Yep. Okay. So that's really handy. Next goal would be around managing cluster lifetime a little better. So with Elastic MapReduce, you have the option to either shut down a cluster right after your work finishes or leave it up. So what often will happen is you forget to shut it down, you run 40 machines for 40 days, and you're sad about the bill. So Mortar provides an additional option which says leave it up so I can do development, but if it sits idle for an hour, then go ahead and shut it down so that you don't accidentally run up bills. And the final one is around having a more granular API than Elastic MapReduce is able to offer. Since they are basically a container that says start and finish and is it running and not a lot else, and Mortar knows more about what's happening, we're able to give you information about more granularly about map and reduce and tasks and progress through those. You can pick up your results via API. If there are errors, those will come back to you through the API in an understandable way. So. So a quick recap of what we've seen so far. We talked about collaboration. So you saw that we took an existing project that Jeremy or I had created, and we can immediately run it without doing any setup, and all the setup that is necessary happens automatically. And so that enables real collaboration. We talked about how you can do fast, free development and see what's happening very, very quickly with the watch command and some other facilities that we didn't show. We showed you how you can do automated testing, and then we looked at debug in Lipstick. We talked a little bit about reproducibility, saying what you ran, how to roll back, and then that grab bag of things that we just showed. So so if you want to actually look at this, the simple project yourself and run it yourself, you can get it at bit.ly/mortar-reinvent. There's documentation all about Mortar and the framework at help.mortardata.com. You can follow us on Twitter. If you want to get started and sort of play around even easier before you use a gem installer and install this framework, you can use we have a web project editor, so it's a built-in IDE in the browser. It's for simpler projects that only have one pig and one Python file, but it's really useful. You can do all the kinds of things that you would be able to do in a framework on a simpler project. For example, one of the things that's nice is we have pig statement templates. If you're not familiar with pig, you can just ask it to insert a statement, for example, like a store Mongo statement, and that'll put that right in there. You can explicitly validate the script to make sure it'll run. You can fire up clusters by saying run, et cetera, and you get all the same snapshotting that we just showed you around history and facilities around Lipstick too. So one of the things that might be on your mind is like, okay, so I get that there's an open source framework and that's free and you run that forever. How does Mortar make money? We're looking at this Mortar interface. So what we did earlier this week was we released a public plan where if you're willing to share your code with the community at large, this is very much like the way GitHub does their pricing. If you have a public repo, then you can use GitHub for free. If you have public repos for Mortar, you can use Mortar totally for free at unlimited scale and all the features as well. And is there anything else I wanted to cover?
I think so.
Okay. So any other questions? Yeah.
So
Sorry, the question is about spots? This year, there will be spots. We didn't start off with that because we figured that we wanted it to be reliable first and not have things drop out. There's just a little more complexity around that. But we're working on it right now. Yes?
So when you're running your test suite, like fixing the bugs when you're running tests, it takes like 17 seconds. How much is it is actually like deep setup, tear down, and can it be sticky soon and rerun the tests quicker? When you launch?
Yeah, that's, so I didn't mention that the test is actually a plugin to the open framework because we consider it beta because it's a little too slow. It's a lot around the setting up and the running the Hadoop, and it should be faster like the way Watchtower is. But we haven't done that yet. But yeah.
What does it cost for non-public repos?
Currently, there is just an upcharge on top of your usage. It's a couple cents depending on your, how much you're using. We're going to be switching over to a subscription model in the new year, where you just have pass-through and subscription.
Okay.
Yeah. Aside from Git, how would we do it? I mean, it's not really built in, right? But so like, let's say you store your stuff in Subversion. I can get it out and run it immediately. Now, there's some of the functionality that we have around pushing to get to be released that wouldn't work, but certainly in terms of the collaboration, it doesn't depend on any particular repository.
And you can also actually, if you have your own private GitHub repo, then it's easy to have that as your sort of, that's what you use to manage your source control, and then the Mortar one is more of just for the pushing and the snapshotting of the actual runs. But it works seamlessly with two separate sort of remotes.
Yeah.
Just GitHub or like we're letting GitLab open, for instance. So it's Git, but it's not GitHub.
So that would be okay. Like you could have your code there as well. But it would still use GitHub for the pushing of the snapshots to Mortar, but you'd still do all your branch management and stuff through yours.
Okay, no more questions? Great, thank you.